they narrowly escaped an Olympic fiasco. But T3 will not suffer this fate. Workers build a giant glass train station and lay train tracks to shuttle millions of passengers to Beijing. Engineers must now ensure the tracks will cope with the load.
What we have to do now is test the construction. We simulate a train in a heavy load situation. Done! One more. Lift this side higher. Done! Are you ready yet? Ready! Cut! Done!
The test is successful, but engineers will have to inspect miles of track before the first Olympic visitors arrive. All passengers arriving at T3 by train will be greeted by Foster's iconic entrance, a giant 800-meter-long overhanging roof. Mr. Zhang's team at Terminal 3A is ready to start welding this structure, but just as work gets underway, engineers realize they're in big trouble. It's an unforeseen problem. The overhang is just too big. It'll stop light from getting into the terminal. Engineers must find a solution, but this will take time. With the Olympics fast approaching, it's time they don't have to spare. October 2005, and Beijing's new Terminal 3 is well underway. Mr. Zhang's construction team is about to start work on the main entrance to Terminal 3A on the south side of the site. Lord Foster has designed a signature piece, an 800-meter-long, 65-meter-wide cantilevered overhang. This sweeping curve is a key architectural statement. But there's bad news.
We ran into a problem in the middle of construction. The original width of the overhanging roof was too large and would cause insufficient indoor light.
It's an unforeseen problem. Engineers could increase the number of skylights to compensate, but this solution could wreck Foster's iconic design. They will have to shrink the overhang. It's cut back from an awe-inspiring 65 meters down to just 35. The entrance will be less dramatic, but it's the only way to ensure Foster's super terminal is flooded with light. Lord Foster also created an extraordinary roof design. The concept looked stunning, but Chinese engineers have never built a roof like it. Engineer Mr. Zhai is daunted by its complexity.
We have never come across something this big. We have never done anything like this before. The many curves also made our construction difficult.
The rolling curves of the dragon's back may be difficult to form from steel, but the dragon scales will also pose a challenge to engineers. The positioning of all 361 skylights will be critical to optimizing the sun's rays in T3. Arup engineer Roger Olsen must make sure each one is in the best location.
The vertical parts of the roof light face southeast, and that lets the early morning sunlight in. And then as the sun climbs higher in the sky, it goes through the horizontal glazing.
With each skylight now located, the iconic dragon roof begins to take shape.
That was a phenomenal kind of experience, actually seeing the roof structure being sort of stitched together throughout the footprint of the building.
They install 300,000 square meters of roofing panels in just 4 months. With the roof near completion, Terminal 3 is a step closer to the impending deadline. The 2008 Olympic Games will bring a surge of visitors. To cope, Beijing must undergo one of the biggest transformations in its history. Terminal 3's completion on time is central to the city's ambitions.
The project has a really short construction period. We have to put it into use by the 2008 Olympics and make sure it serves the Olympics smoothly, which puts great pressure on us.
As the Olympic clock counts down, her team must think about airport safety. For the terrorists, Terminal 3 could provide an attractive target. The baggage system must be made terrorist-proof. Yet with the volume of luggage going through this terminal every day, an estimated 250,000 bags, it's a tall order. The world knows what just one rogue suitcase can do. In 1988, Pan Am Flight 103 took off from London Heathrow, heading for New York. Less than an hour into the flight, the plane exploded in mid-air over the village of Lockerbie, Scotland. People and debris rained down from the sky. In all, 270 people were killed. It's a security expert's worst nightmare. No one wants another Lockerbie on their hands.
Certainly, Lockerbie does enter into your thoughts relative to your baggage, to making sure your baggage is secure, that it is safe, that you don't have contraband, explosives, anything that's not supposed to be in there.
The chance of a bag containing a bomb is less than 1 in a billion. But passengers want to know they are totally safe. Jeff Martin believes Terminal 3's security system offers the best protection available.
I'm certainly confident with the state-of-the-art technology, the new systems using the computed tomography, that the bags that do get on the airplane are safe.
It's one of the world's most advanced X-ray systems. Developed in Germany in their airport laboratory, Siemens have created the ultimate security machine. State-of-the-art scanners will examine 600 bags per minute. Powerful computers search for traces of explosives at lightning speed. Jeff and his team have minimized the potential bomb threat, but now have an everyday problem to contend with. How to transport bags between Terminals 3A and 3B, a distance of over 2 kilometers.
A conventional conveyor system wouldn't work, so it required new technology, an updated technology of a higher speed conveyor system.
In place of a conventional conveyor, they install a 4-stage high-speed belt to whisk bags from T3A to T3B. Luggage is accelerated to 40 kilometers per hour in just 5 seconds.